Good day class. Today we're looking at Theorem 2. The diagonals of a palm bisect each other. So the diagonals will be these: MP and PR, MP and PR, NP and PS. That would be the diagonals. Required to prove the diagonals of a palm bisect each other. First we're looking at these two triangles, triangle MPN and triangle RPS. We are going to prove that those two triangles are congruent and therefore they fit on each other. So if they fit on each other, that would mean that this piece will be equal to that piece and that piece will be equal to that piece. That's if we can prove that this whole triangle is congruent to this whole triangle. All we're going to do is add in the ones, and our first statements will be, so if you look, we can see that M1 is equal to R1. What type of angles are those? Alternate angles. MN is parallel to SR. So MN is parallel to SR, so M1 and R1 will be alternate. You can see the Z shape. Again, we can see that N1 is equal to S1. So N1 is equal to S1. Again, those are also alternate angles, MN parallel to SR. All we need is something to give us size, because we have an angle and an angle thus far. All we need is size. If you look nicely, we can see that MN is equal to SR, and we can see that those sides will be equal. Notice that they told us that it is a palm. So if you look on top, and so we can conclude that NP is equal to PR, NP is equal to PS, corresponding sides of congruent triangles, because the one triangle fits perfectly on the other triangle. And so now we have concluded the last statements. Therefore, the diagonals of a palm bisect each other.